first topic, Introduction to Physics, we'll have we'll discuss the measurement. Okay, measurement because we will use this topic all throughout every topics in physics, especially during laboratories. So we will use this topic, the rules on this topic. So everything on this topic, we will use this throughout the semester or even on the second semester. Okay, so measurement. So the objectives for today's discussion: describe the importance of measurement in physics, apply rules of significant figures and scientific notation in measurements, then convert units from one system to another system, so converting units, and last is to cite some applications of physics in real life and its importance in the field of medicine and in engineering. Okay, so when we say measurement, measurement is the assigning of numeral values to describe an object's property. So, to measure an object, we assign numeral values so that we will be able to describe the property of that particular object. For example, the height of a person. So, we use measurement to describe and differentiate objects. So the property of that particular objects. For example, the height of a person. So we use measurement to differentiate and describe a person's height. If, for example, if a person is 6 feet, or if he or she is 183 centimeter or 1.83 meters. So that is assigning some numeral values to describe the object's property within specific unit. So before measuring devices and other means of measurement was developed, the unit or the standardized value, unit is the standardized value for comparison. So before the measuring devices or before measurement was developed, so nung unang panahon, especially in Egypt, so they are using the parts of the body of their current pharaoh to measure something. So they are using the foot of the pharaoh, hands of the pharaoh, the arm of the pharaoh. So, yan. So they are using parts of the body of their current pharaoh. So kung magpapalit sila ng pharaoh, so the standard measurement is also be changed because di naman lahat ng pharaoh is magkapareho ang parts or magkapareho ang haba ng parts ng kanilang katawan. So every time they change pharaohs or their leaders, so the standard measurement or the standard measurement they are using is also be changed. So that is the reason why as time goes by, measurement was also developed. And part of that development is the metric system. Part of that development is the metric system or the unit of the metric system where it is based by the power of 10. So when we say it is based on powers of 10, so it is 10 to the power of 1, 10 to the power of 2, 10 to the power of 3, 10 to the power of 4, and so on. So it could be a positive or negative exponent. So, by the way, so if you have questions and other queries, you can send it in the chat box. And so, chat box nyo lang i-ano yung mga tanong, then we will answer that later after the discussion or before we end our session. So, reserve your question or pwede nyo i-post daan ninyo ang question sa chat box, then we will read and answer it later. Okay? So, okay. The SI system unit or the standard unit that we are currently using. So in the SI system unit, we have two types, or it has two components. So the SI system unit or the standard system unit has two components: the fundamental quantities and the derived quantities. Okay. Sir, what is the difference between fundamental quantities and derived quantities? Okay. When we say fundamental quantities, then it means it is the foundation or the basic units or the basic quantity or the basic unit of the SI system unit. For example, the length, which is the standard unit, is meter. The mass, which is the standard unit, which is kilogram. Time, the standard unit is second. The temperature, the standard unit is Kelvin. The amount of substance, which has the standard unit of mole, then the electric current, ampere, and the luminous intensity, which is the standard unit is candela. So that is, or that are the those are the fundamental quantity or the fundamental units. So how about the derived units? When we say derived units or the derived quantity, it is the combination of two or more fundamental quantities. So when we say derived quantity, it is the combination of two or more fundamental quantity. So for example, the area. So area is the combination of two lengths. So it is a meter square or square meter because it is the combination of two lengths. We also have the volume, which is the combination of three lengths. So a cubic meter. So we also have the speed, which is the combination of length or distance over the time. And we also have the density, which is the combination of mass and its volume. So when we say fundamental quantity, it is the basic units or the basic quantity. And when we say derived quantity, it is the combination of two or more fundamental quantities. So once again, fundamental quantity is the basic unit or the basic quantity, and derived quantity is the combination of two or more fundamental quantities. So that is the SI or the standard system unit of the metric system. Okay. So part of the metric system, we have the prefixes. So the prefixes is, we use prefixes to minimize or para mas maliit or mas konti ang number of digits that we are using on our measurement. Okay, so we have the tera, giga, mega, kilo, hecto, deca, deci, centi, milli, micro, nano, and pico, and some other prefixes. So these are just some example of prefixes, but there are a lot of prefixes that we are using in this time. So these are just some examples. So we use prefixes para mas to minimize or para mas maging konti ang digits or the number of digits that we have to use. So as I have mentioned earlier, metric system is based on the power of 10. And also, metric prefixes is also based on the power of 10. So we have the following. So tera is equal to 10 to the power of 12. Giga is equal to 10 to the power of 9. Mega is 10 to the power of 6. Kilo is 10 to the power of 3. Hecto is 10 to the power of 2. Deca is 10 to the power of 1. Deci is 10 to the power of negative 1. Centi is 10 to the power of negative 2. Milli is 10 to the power of negative 3. Micro is 10 to the power of negative 6. Nano is 10 to the power of negative 9. And pico is 10 to the power of negative 12. So, in every prefixes, there is an equivalent or an equal 10 to the power of an exponent. So, in every prefixes, it has an equal or equivalent power of 10. So, sir, unsa manamo or how can we get those or how to identify the appropriate prefix to be used in our measurement? Okay, so to know what is the applicable prefixes to be used in your measurements, so we need the scientific notations. Okay, so scientific notation, I know you are familiar with scientific notation because you already discussed this during your junior high school. So let's review and rediscuss what is scientific notation. Okay, scientific notation has several rules. So we have 4 rules. 2 of it is a conversion of decimal to scientific notation, and the other 2 is the reverse or the vice versa, which is the scientific notation to decimal. Okay, so how can we convert decimal to scientific notation? Okay, for converting decimal to scientific notation, okay, scientific notation is the movement of decimal place or the decimal point. So scientific notation is the movement of the decimal point. So if the movement of your decimal point is from right to left, so if the movement of your decimal point is from right to left, then the exponent of your or the exponent is positive. But if the movement of your decimal point is from left to right, then the exponent is negative. Okay, remember, if the movement of your decimal point is from right to left or right to the left, then the exponent is positive. If the movement of your decimal point is from left to the right, then the exponent of your scientific notation is negative. Okay, so let's have an example. Okay, so we have 1,391,000 meters. Okay, so we will convert this decimal to scientific notation. Okay, Sir Asamandia, you said that scientific notation is the movement of the decimal point. But in this case, sir, walang may decimal point. Okay, so always remember that a whole number, the decimal point of a whole number is at the end part or the after the last digit of your whole number. So in this case, 0 is the last digit, so therefore your decimal point is at the after the last digit of your whole number. Okay, so convert 1,391,000 to scientific notation. So just simply move the decimal point. So if we move this to 1, so count 1, 2, 3, 4, 5, and 6. So at 1.391, we move 6 places to the left. So therefore, since we move 6 places to the left, then the exponent will be the number of the movement of decimal place, and its signs depends on the movement of your decimal. So since we move to the left, so therefore it is positive. And since we move 6 places to the left, so now it will become 1.391 times 10 to the power of 6. Okay? So remember, if the movement is from right to the left, then it is positive. And if the movement is from left to the right, therefore it is negative. And the number of movement of your decimal point is also the number of exponent or the exponent you will place at the 10th power. Okay, next example. So we have 0.0000000 and 911 grams. Okay, so from this decimal point, we move up to the 9, so that we can have a whole number 9. So we count the number of movement. So 1, 2, 3, 4, 5, 6, and 7. So since it moved up to 7 places, so therefore 7 is the exponent of our, or the power of our 10. And since the movement is from left to right, so therefore 7 is negative. So from 911 grams, so it becomes 9.11 K. So this is not 10, this is negative 7. So 9.11 times 10 to the power of negative 7. So since we move the decimal point by 7 places and we move it from left to right, so therefore the exponent of your 10 is negative 7. Okay? Okay, so far so good. Okay pa? Okay pa ang tanan? Okay, kindly hit
Yes,
the like.
sir.
Kindly hit the like button if okay pa mo. Kasi nalay kalit pa kuya Pandya. Oh, laban ng ulo ni Carla. Okay? So, proceed. Medyo mahaba-habang usapan pa to. Okay. So now let's proceed. Okay. So that is for the rule of the scientific, the decimal to scientific notation. Okay, this time we'll proceed with the scientific notation to decimal. Okay, if kanina in decimal to scientific notation, the movement of the decimal point from right to left is positive and from left to right is negative. So this time, if the exponent of your scientific notation is positive, so the movement of your decimal point is from left. So from left going to the right. So that is the movement of your decimal point. So it is from scientific notation to decimal. And if the exponent of your scientific notation is negative, then the movement of your decimal point is from right. So from right, it moves to the left. So from right to the left. So that is the movement of your decimal point if you convert scientific notation to decimal. But most of the time, we will only just use converting decimal to scientific notation. Most of the time, there are also some instances where we have to convert scientific notation to decimal. But most of the time, it is decimal to scientific notation. Okay, so that is the movement of your decimal point. Okay, so for example, if we have 6.022 times 10 to the power of 23 particles, okay, so since the uh, power of your 10 is positive or the exponent of your 10 is positive, so the movement of your decimal point is going to the right. So the movement is going to the right, so just count 23 places to the right. So 1, 2, 3, 4, 5, and so on till you reach the 23 point. Okay. Sir, what will happen to the movement of the decimal point which has no number or which has no digit? So for those movement of your decimal point that has no digit or no number, so just put 0 on it. So in every movement na walang number, so ilagay nyo ang 0. So in this case, 6.022 times 10 to the power of 23. So move 23 places to the right. So the result is, so ito. So we move from here, which is 6 point. So we move 23. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, and 23. So we move 23 places to the right since it is positive. Okay, so how about if it is negative exponent? So we just simply move the decimal point to the left. So from 2.34 times 10 to the power of negative 8. So just move 8 places to the left. Okay, so from 2.34, so we move 8 places. 1, 2, 3, 4, 5, 6, 7, and 8. So therefore, we have 0.000000023 kilograms. Okay, so that is the movement of your scientific notation to decimal and decimal to scientific notation. Okay, just always remember that when we say it, if it is a positive exponent of your 10, then it means that it is a very big number. For example, 6.22 times 10 to the power of 23. So since it is positive, then it means it is a very big number. So the result is a very big number. And when the exponent or the power of your 10 is negative, just like 2.34 times 10 to the power of negative 8. So since it is negative, then it means it is a very small number. So from 2.34 times 10 to the power of negative 8. So since it is negative, so it simply means it is a very small number, which is a 0.0000023. So it means a very, very small number. So when positive exponent, a very big number. When a negative exponent, then it means a very small number. So always remember that. Okay, so as I have mentioned earlier, in every prefixes, so there is an equivalent scientific notation, or it has an equivalent exponent. So for example, for tera, which is equal to 10 to the power of 12, then the milli, which is 10 to the power of -3. So to apply the following prefixes, make sure that you know how to convert decimal to scientific notation. For example, in this case, so we have 5 trillion and 100 billion byte. So from 5 trillion and 100 billion byte, so as I have mentioned earlier, prefixes is used para mas malesen or para mas konti ang number na kailangan mong isulat, or to lessen the number of digits of your measurement. For example, in this case, so di ba, masyado siyang mahaba or masyadong marami. So that's why we have to apply, or we apply prefixes para mas mapaliit or mas mapakonti ang number of digits on this given measurement. So from 5 trillion and 100 billion byte, we convert this to tera. So we applied the prefix tera. So since tera is 10 to the power of 12, then we move the decimal point 12 places to the left. So from here, which is the decimal point, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So therefore, we have 5.1 times 10 to the power of 12. Okay. So this is the scientific notation of the 5 trillion 100 billion bytes. So from scientific notation, then we will apply the appropriate prefix. So 10 to the power of 12 is also equal to tera. So imbis na ang ilagay nyo is times 10 to the power of 12, replace power or replace times 10 to the power of 12 with the appropriate prefix. For example, 5.1 times 10 to the power of 12. So replace times 10. So we replace times 10 to the power of 12 with the appropriate prefix, which is the tera. So the final answer is 5.1 terabyte. So imbes na ang ilagay natin is times 10 to the power of 12, then we replace this with the prefix tera. So the symbol of tera is capital letter T, then add the given unit. So in this case, we have byte. So 5.1 terabyte. Okay, sir, what if, sir, ang gusto na ko gamitin, sir, is mega. So si mega lang. So we move 6 places to the left. So 1, 2, 3, 4, 5, and 6. So therefore, it is 5,100,000 times 10 to the power of 6. So replace your scientific notation with the following prefix. So the answer is 5,100,000 megabyte. Okay, same with the other prefixes. So I repeat, once you apply the appropriate prefixes, so that means that you do not have to write times 10 to the power of 12. Nga naman, so double kill na siya, magbutang na ka times 10 to the power of 12 yan, magbutang pa yun ka o prefix, so redundant na kayo, balik-balik na. So kung magbutang na ka o prefix, so that means na dili na nimo kailangan nga maglagay pa ng times 10 to the power of its exponent. Okay? So another example. Diri ana punta, so we are done with the positive exponent. Then let's proceed with the diri ana punta maghatag og example sa negative exponents. Okay. So for the negative exponent, we have deci, centi, milli, micro, nano, and pico. So in each movement of your decimal point, so for example, we wanted to use milli. So since milli is 10 to the power of negative 3, so we move 3 places to the right. So 1, 2, and 3. So therefore, it is 0.024 times 10 to the power of negative 3. So, imbes na ang ilagay natin is 0.024 times 10 to the power of negative 3, then we apply the appropriate prefix, which is 3 milli. So 0.024 milligrams. So same with the centi and the deci. So ganyan lang. So just practice converting decimal to scientific notation. Then after you convert decimal to scientific notation, then apply the appropriate prefixes. Okay, so because as I have mentioned earlier, we will use this topic for the rest of the topic for the general physics 100, including the first semester and the second semester. We'll continue our discussion for today with our discussion on the scientific notation. Okay. So, as we continue, we'll have the significant figures. Okay. So, what are significant figures? Okay. So, significant figures are digits known with certainty and an estimated digit. So in measurement, significant figures are digit known with certainty or yung measurement mo na sure ka talaga and an estimated digit. So in measurement, these are significant figures are digits with certainty or yung certain which your measurement that is sure and an estimated digit which is the last digit of your measurement. So your measurement device, the significant figures depends on the calibration of your measurement device. So for example, in this ruler, you have a pencil. So a pencil and a ruler which is calibrated by tens. So in this measurement, you are sure that the pencil is between 0 and 10 because this ruler is calibrated by 10. So it is calibrated by 10, 20, 30, 40, and so on. So you are sure that the pencil is between 0 and 10 and it is less than 10 but it is greater than 0. So that is the certainty. You are sure or you are certain that it is less than 10 and greater than 0, but you are not sure if what is the specific measurement in ones. So in tens value, you are sure that it is less than 10, but the ones value is the estimated digit because you are uncertain of the specific measurement. So you estimate. So if this is 5, which is half the 10, then 6, 7, then we have 8 and 9. So this is 5, 6, 7, 8, and 9. Okay, so assuming these are the measurement of these digits, so based on our estimation or on our assumed measurement, so we can say that the pencil is on the number 8. So we assume or we estimate that the measurement of this pencil is 8. So we assume that it is equal to 8. So for example, the unit is centimeter. So we assume or the estimated digit or the estimated measurement of this pencil is 8 centimeter. So the significant figures on this measurement is 8 centimeter, which is an estimation based on our measuring device that is calibrated by tens. So what would happen if our ruler or the measuring device is calibrated by ones? So for example, in this case, so if this is 10, so if this is 10, then we have 9, 8, 7, 6, and 5, and so on. So if this is the, okay, so if this is 9, 8, 7, 6, and 5, yung kanina, we just estimate the places of these digits, but this time we are sure that these lines are the accurate lines of our measurement. So this time we are sure that the measurement of this pencil, which belongs to 8. So this time we are sure that it is or falls under the measurement of 8 centimeter. So since we are sure or we are certain that it belongs to 8, so now we estimate, as we can see, the point of the pencil or medyo nalapas or medyo lapas ang point sa pencil. So as you can see, the point of the pencil, hindi siya nasa exactly line of the 8, hindi may konti siyang or nalapas siya gamay sa line sa 8. So therefore, we estimate again the measurement of that particular, or we estimate again what is the measurement of this pencil. Okay, so since it is 8, so 8 centimeter. So since this is calibrated by ones, so point. So if this is 0.5, 0.4, okay, so we have 0.1, 0.2, 0.3, 0.4, and 0.5. So now we estimate what is the digit or what is the measurement on its decimal place. So since this is 0.1, then 0.2, so we assume that it is equal to 2. Okay, so we have 8.2 centimeters. Okay, so in significant figures in measurement, you have a certain digit or yung measurement that you are very sure, and an estimated digit or an assumed digit. So in this case, 8 is our certain digit and 2 is our estimated digit. Okay. In measurement, significant figures in measurement, the estimated digit is the last digit of your measurement. It is always the last digit of your measurement. Okay. Sir, what if siya lang isa, sir? For example, 8 centimeter. Okay. So, for example, 8 centimeter. You said that the estimated digit is the last digit of your measurement. So, how about if siya lang isa? So, if siya lang isa, so therefore, we can say na siya ang first, siya po ang last na digit of your measurement. So therefore, we can assume that this measurement is an estimated digit. And for those which has 2 or more digits in measurement, so the last digit is always the estimated digit um, regardless of its place. So 8.2, which 8 is our certain digit and 2 is an estimated digit. So that is the significant figures that is calibrated on 1. So the number of significant figures depends on the calibration of your measuring device. For example, in this case, your measuring device is calibrated by ones. So therefore, your significant figures or the estimated digit is the place value below your calibrated or the calibration of your measuring device. So example, in this case, the calibration of ruler is in ones, so therefore the estimated value is the tenths value of your decimal place. So make sure, so notice siya, if your estimated value is always the last digit of your measurement. Okay? So, another example, kini, mas specific na siya because it is calibrated by 0.1 or in tenths. So, in tenths, decimal place tenths, so it is calibrated in 0.1. So therefore, it is more specific than the past or the yung mga example natin kanina. So if this is 9, then this is 8. So we can say that the pencil is 8 point. So since it is calibrated by 1 or by 0.1, so this is 1.2, and as you can see, the pencil is, the tip of the pencil falls on the second line after the 8, so therefore it is 8.2. Then since it is calibrated by 0.1, then our estimated value should be a place after the calibrated value of your measuring device. So if this is the calibrated value, then the estimated value is the digit after this. So since medyo naalam siya sa tip sa ato ang sa second line, so we assume or we estimate that it is equal to 0. So therefore we can say that this measurement is equal to 8.20 centimeters. So that is the measurement of this specific example. So remember, your estimated value is a place value after your calibrated value. So in this case, the calibrated value is in tenths or 0.1. So therefore, your estimated value should be a place value after the calibrated value, which is the hundredths place. Okay? Okay, so after measuring, especially in laboratory, as you have measured your objects or the given objects, so therefore, there are some instances where we have to apply operations. So we add, we subtract, we multiply, or we divide the measured digits. So in applying operations in significant figures, there is a certain rule in applying operations in significant figures. So for addition and subtraction, so the answer should have the least decimal point. So in addition and subtraction, so the answer should have the least decimal point. So your answer should have the least decimal number, or the least number of decimal places. So that is for addition and subtraction. So for example, if we have 13.54 plus 9.120, okay? So 13.54 plus 9.120 is equal to 6 to, so 22.660. So that is the, so 13.54 plus 9.120 is equal to 22.660. Okay, but according to the rule of significant figure, the answer should have the least decimal, or the least number of decimal places, which in this case, si 13.54 has the least number of decimal places. So which has 2 decimal places, than 9.120 which has 3 decimal places. So from 22.660, the final answer, if we follow the rule, so it became, so 22.660 convert to 2 decimal places. So is equal to 22.66, and that is your final answer, because we must follow the rule that the answer should have the least number of decimal places. Okay, regardless of the number of the, so regardless of the number, so we have here 19.047 minus 2.3 plus 73.689. So always follow the least number of decimal places. So that is for addition and subtraction. So for example, so 19.047 plus 2.3 minus 2.3, so it is equal to 747, then 861, then plus 73.689. So we have 6, carry 1, 13, carry 1, so 14, carry 1, 10, carry 1. So we have 90.436. But according to the rule, we should follow the least number of decimal places. So according to the given, 2.3 has the least number of decimal places, which only has 1 decimal place. So we will follow the least number. So we cut this up to the 1 decimal place. So the answer is 90.4. Okay? So always follow the rules in significant figures. Okay, that is for addition and subtraction. So, how about for the multiplication and division? For multiplication and division, answer should have the least number of significant figures. Okay? So answer should have the least number of significant figures. But sir, kung saan man ang pagkabalo ang number of significant figures? Okay. Para malaman natin kung ilan ang number ng significant figures, there are certain rules that we have to follow to identify if the digit is significant or not. Okay, first, all non-zero digits are significant. Okay, all non-zero digits are all significant. So 1, 2, 3, 4, 5, 6, 7, 8, 9, they are all significant. Okay. So the crucial part is in the zeros because zero may significant or may not. So how can we identify if the zeros are significant or zero are not significant? Okay, first is zeros between non-zero digits are all significant. So zeros between non-zero digits are significant. For example, 5,010,965 kilometer. Okay, so count the number of significance. Okay, first, all non-zero digits are significant. So we have 1, 2, 3, 4, and 5. So they are all significant. Okay, next, the crucial part is in the zeros. Okay, according to the rule, zero between non-zero digits are significant. So these three zeros are between non-zero digits. So therefore, we can consider this as significant. So count 1, 2, and 3. So all in all, we have 1, 2, 3, 4, 5, 6, 7, and 8 number of significant figures. So always remember the number of significant figures. The crucial part of identifying the number of significant figures is on the zeros. Okay. So leading zeros are not significant. So if kanina, every zero that is between non-zero digits are significant. So this time, leading zeros are not significant. So what does it mean when we say leading zeros? Leading zeros are those zeros serves as a placeholder in the decimal point. So for example, in this case, so these are leading zeros. So they are zeros that has no non-zero digits before it. So it serves as a placeholder on the decimal point. So 0.0000. So those or these zeros are not significant. So they are considered as not significant. So to count the number of significant figures on this matter, so we have 1, 2, and 3. So we have 3 number of significant figures. So remember, leading zeros are not significant. So those are zeros used as a placeholder on decimal point. So in this example, these are an example of leading zeros. Okay, so another example, are leading zeros. So we have 1 and 2, so two significant figures. Okay. If leading zeros are not significant, trailing zeros with decimal point are all significant. So what do we mean by trailing zeros? So those are zeros in the end part. So regardless if it has a non-zero digit between it or none, as long as it has a decimal point, so therefore we can consider it as significant. So example, 100 point Kelvin. So 100 point Kelvin. So this is an example of a trailing zeros with decimal point. So therefore, if it has a decimal point, then we can consider it as significant. So the number of significant figures are 1, 2, and 3. Okay. Sir, how about if wala siya decimal point? Okay, if wala siya decimal point, for example, in this case, so we have 71 million and wala siya point at the end. Wala siya decimal point at the end. So therefore, we consider this as not significant. Okay. Remember, trailing zeros without kanang walay decimal point are considered as not significant. So in this case, sir, ano dili man siya ma-considered as not significant? Because they serve as a placeholder, same with the leading zeros that are not significant. Every zero every zero serves as a placeholder, is considered not significant. So in this case, the number of significant figures is 1 and 2. Okay. So, para hindi siya nakakalito if how many significant figures ang ang meron ka, so you can either convert it to scientific notation or apply prefixes. So para mas madali sa pag-count ng kanyang number of significant figures, you can apply the scientific notation or apply the prefixes para hindi siya nakakalito. For example, in this case, so 71 million. So we move 1, 2, 3, 4, 5, 6, and 7. So we have 7.10 times 10 to the power of 7. So ilan ang significant figures? So we have 1, 2, and 3. So we have 3 significant figures. Sir, do we have to count times 10 to the power of 7 as significant figures? Not necessary. So hindi na kailangan na isali nyo pa ang times 10 to the power of 7. So, okay, if you convert your measurement into scientific notation or apply the prefixes, the number of significant figures also changes depending on the prefix you are using. Okay? Okay, so that is how to identify the number of significant figures, which will be applicable on the operations on multiplication and division. So answer should have the least number of significant figures. Okay, for example, if we have so for example, if we have what is the velocity of a car which covers 102.509 meters in 30.5. So if the velocity is equal to distance over time, we just simply divide 102.509 then divided by 30.5. Okay, so that is the, so what the calculator. Okay, so 102.509 divided by 30.5. So it is equal to 3.3609550 K and so on. K. So according to the rule, answer should have the least number of significant figures. Okay. In this case, 102.509 has 6 significant figures and 30.5 has 3 significant figures. So therefore, we will follow the least number of significant figures, which is equal to 3, and the final answer is, so the final answer is 30.3.36 meter per second. So that is the final answer, and that is for the rule in significant figures. Okay, speaking of rounding rule, so we have the rounding rules in significant figure. I know you're already familiar with the rounding up and the rounding down. So for rounding down, if the number is or less than 5, 50, 500, and so on. So if it is 1, 2, 3, and 4, then it is left unchanged or you round down. So for example, 149 round to its nearest hundreds. So since it is equal to 4, so therefore you round down or left unchanged. So left unchanged, so therefore it is equal to, so therefore it is equal to 100. So for 9,499, round to its nearest thousands. So since it is equal to 4, so it is equal to 9,000. I know you are familiar with this rule. So for round up, if it is equal to or greater than 5, if it is 6, 7, 8, and 9. So if it is 6, 7, 8, and 9, so you round up or you increase it by 1. For example, 189. So round to its nearest hundreds. So 189, since 8 is greater than 5, so you round up, you apply rounding up. So from 189, so round up, so it became 200. So I know you are familiar with these rules, but the crucial part is if it is equal to 5. So rounding with 5, 50, 500, and etc. So if it is equal or exactly equal to 550, 500, and etc. So these are the this is the crucial part, because I know some of you may say that according to our junior high school teachers, if it is 5, then we apply round up. but it does not always round up. It could be round up or round down if it is equal to 5. Sir, kung saan na mo pagkabalo if round up or round down. So, if it is an even number or an odd number, okay. For even number, for example, 145. So round to its nearest tens. So as you can observe, 5 or equal to 5. The next is the tens place is an even number. Okay, for even number, so round to its closest even number. So for even number, you retain or you remain the original number. So round to its nearest tens. So since it is an even number, so remain. So we have 140. Sir, ngano 140? Why 140? So as I have said, if it is equal to 5 or exactly 5, then you round to its closest even number. So in this case, 145 round to its nearest tens. So 145 is equal to 140. So sir, how about if it is even number? Okay, for even number, for example, in this case, 155,000. So round to its nearest 10,000s. So as you can see, the 10,000s is an odd number. Okay, if it is an odd number, closest even number, so the closest even number is dili man pwede nga ato siyang baba of 4. So the closest even number is, the possible closest even number is 6. So because dili man pwede nga ato siyang ibaba og 4. So always dito ata siya, the closest possible number is 6. So from 155,000 round to its nearest 10,000s, so it is equal to 160,000. So that is if it is exactly or equal to 5. So for odd number, round up. For even number, we retain the original even number. Okay, so what if, okay, what if in this case, 155,100, so we round to its nearest 10,000s. Okay, so that example earlier is for exactly 5. If wala na siyang kadugtong na number, if 5 lang talaga siya, then 0, 0, 0. But if in case from 5, then 0, 0, 0, 1, or naa siya'y kadugtong na number, then we round up. So in this case, round to its nearest 10,000s. So it is 5, but after 5 may number siya. So my number after 5. So in this case, we round up. So 160,000. Okay, always remember, if 5 pero may kadugtong siya, then we round up. But if it is exactly 5 lang talaga, wala siyang kadugtong na number or wala siyang number, or the succeeding numbers are all zeros, then we apply the odd even rules. But in this case, if it is 5 and the succeeding number, it has a non-zero digit, then we round up. Okay, remember, for 5 and the succeeding numbers are all zeros, we apply the odd and even rules. For 5 and the succeeding numbers, it has a non-zero digit, then we round up. Okay? Are we clear? Okay? Are you still with me?
Sir.
Okay. If you are, okay, kindly hit the like button if are we clear? Okay, so may I request everyone to um, please kindly turn on your camera. So kindly turn on your camera. Okay. So 5, 4, 3, 2, and 1. Okay. So I think wala na tayo time. Then we will continue this next meeting. So see you on Paper on Thursday. Speaking of rounding rule, so we have the rounding rules in significant figure. I know you're already familiar with the rounding up and the rounding down. So for rounding down, if the number is or less than 5, 50, 500, and so on. So if it is 1, 2, 3, and 4, then it is left unchanged or you round down. So for example, 149 round to its nearest hundreds. So since it is equal to 4, so therefore you round down or left unchanged. So left unchanged, so therefore it is equal to, so therefore it is equal to 100. So for 9,499, round to its nearest thousands. So since it is equal to 4, so it is equal to 9,000. I know you are familiar with this rule. So for round up, if it is equal to or greater than 5, if it is 6, 7, 8, and 9. So if it is 6, 7, 8, and 9, so you round up or you increase it by 1. For example, 189. So round to its nearest hundreds. Hundreds. So 189, since 8 is greater than 5, so you round up, you apply rounding up. So from 189, so round up, so it became 200. So I know you are familiar with these rules, but the crucial part is if it is equal to 5. So rounding with 5, 50, 500, and etc. So if it is equal or exactly equal to 550, 500, and etc. So these are this is the crucial part, because I know some of you may say that according to our junior high school teachers, if it is 5, then we apply round up. But it does not always round up. It could be round up or round down if it is equal to 5. Sir, kung saan na mo pagkabalo if round up or round down. So, if it is an even number or an odd number, okay. For even number, for example, 145. So round to its nearest tens. So as you can observe, 5 or equal to 5. The next is the tens place is an even number. Okay, for even number, so round to its closest even number. So for even number, you retain or you remain the original number. So round to its nearest tens. So since it is an even number, so remain. So we have 140. Sir, ngano 140? Why 140? So as I have said, if it is equal to 5 or exactly 5, then you round to its closest even number. So in this case, 145 round to its nearest tens. So 145 is equal to 140. So sir, how about if it is even number? Okay, for even number, for example, in this case, 155,000. So round to its nearest 10,000s. So as you can see, the 10,000s is an odd number. Okay, if it is an odd number, closest even number, so the closest even number is dili man pwede nga ato siyang baba of 4. So the closest even number is, the possible closest even number is 6. So because dili man pwede nga ato siyang ibaba og 4. So always dito ata siya, the closest possible number is 6. So from 155,000 round to its nearest 10,000s, so it is equal to 160,000. So that is if it is exactly or equal to 5. So for odd number, round up. For even number, we retain the original even number. Okay, so what if, okay, what if in this case, 155,100, so we round to its nearest 10,000s. Okay, so that example earlier is for exactly 5. If wala na siyang kadugtong na number, if 5 lang talaga siya, then 0, 0, 0. But if in case from 5, then 0, 0, 0, 1, or naa siya'y kadugtong na number, then we round up. So in this case, round to its nearest 10,000s. So it is 5, but after 5 may number siya. So my number after 5. So in this case, we round up. So 160,000. Okay, always remember, if 5 pero may kadugtong siya, then we round up. But if it is exactly 5 lang talaga, wala siyang kadugtong na number, or wala siyang number, or the succeeding numbers are all zeros, then we apply the odd even rules. But in this case, if it is 5 and the succeeding number, it has a non-zero digit, then we round up. Okay, remember, for 5, and the succeeding numbers are all zeros, we apply the odd and even rules. For 5 and the succeeding numbers, it has a non-zero digit, then we round up. Okay? Are we clear?